Ladies and gents, welcome to another flip session of chemistry. Today we're going to be talking about molecular formula. So we've recently discussed empirical formula, the lowest reduced subscript values for a given formula. The molecular formula today is going to be a multiple of the empirical. In other words, all molecular formulas have some empirical formula that they're a multiple of in the number of atoms and of its molar mass. So looking at some of the notes today, we're going to calculate molecular formula from empirical formula, and just a couple of side notes about what the molecular formula is. Right? So the molecular formula is going to indicate the types and specific number of atoms that make up a chemical substance. Okay? It's not always, actually it's usually not expressed in lowest mole-to-mole ratios. In other words, molecular formulas are almost never empirical formulas. Sometimes they are, but in many instances they're not. They're multiples of the empirical. All right, so we're going to take a look at some of these today. So, sample problem here, we're going to work through together. Okay, I'm going to read this if you can't read my handwriting. So we have a compound that contains carbon, hydrogen, and oxygen. Okay. 3 elements. Here's the masses. Right? Here's our carbon's percentage and our hydrogen's percentage. They don't give us in this problem the oxygen percentage. But that's pretty easy to do, right? If there's only 3 elements and they give us 2, we know all 3 elements have to equal 100%. So I'm going to add up 63.16 and 8.77 and deduct that from 100%. And that's going to tell me the remainder of what's oxygen. Okay. Evidence indicates that the compound has a molar mass of 114 grams per mole. So this is the molar mass, right? NM, molar mass of the molecular formula. And that's what they want us to find. What's the molecular formula? Okay. So I look at this problem and I think to myself, I don't have a specific amount. They don't give me grams, they only give me percentages. Percent per 100. So let's assume we have a 100 gram sample. If we have a 100 gram sample, if this is the value per 100, then these two numbers here, 8.77 and 63.16, simply go from percentages to grams. It's a real easy assumption. Right? So we're going to do that. So solution to this, I assume I have a 100 gram sample. My percentage values change to grams. And what's left over from 100 is 28.07 grams of oxygen. I got this number by adding 63.16 and 8.77 and deducting those values from 100. Your next step is you're going to take these gram amounts and convert them to moles using molar mass of each element. And that's what I did here. I'm basically taking the mass of each element and I'm dividing it by the molar mass. So now we have a mole to mole to mole ratio in this compound. All right? So I can't stick with these numbers. They're decimals. Right? They're not whole numbers. So I'm going to take the lowest number right here and I'm going to divide all the mole amounts by 1.754. I do that to get my lowest number down to 1. Right? And that math looks like this. I've color-coded the elements here, right? Carbon's in red, hydrogen's in blue, and oxygen in green. So I take oxygen's value, I divide it into all the other values for moles. This becomes 1, this becomes 5, and this quotient becomes 3. So now we have an empirical formula, right? Lowest reduced terms. But that's not what the question was asking. They said find the molecular, okay? So I know my molecular formula is going to be some multiple of 3, 5, 1. It could be 6, 10, 2. It could be 9, 15, 3. Some multiple of this. Okay. So let's find out what the molar mass is of the empirical. Okay. So the molar mass of the empirical formula is 57 grams. So I need to find out how many times is the molecular formula a multiple of the empirical. Right? So the way to figure that out, I take my molecular formula, its molar mass, which was 114, right? This was given in the problem, and I divide that by the molar mass of the empirical, which we just figured out. It's a factor of 2. So my last step is I take my factor, and I know that my actual formula is double of my empirical formula. Right? So I multiply the 2 throughout all the subscripts, and this, folks, is your answer. This is your molecular formula. Keep on practicing, keep on watching the videos. I'm having some students tell me they're not getting the gist in all the videos. My response to that is watch it again, right? Like any movie, if you watch it over and over again, you're going to be surprised on which parts you miss. Right? So there may be some parts that you missed during the video, so it doesn't hurt to watch them again. All right? Have a great day, and I'll see you in class.